Yay, 2024 pens are finally done. I'm supremely happy with them. Took about a week longer of design than I wanted them to take, but yeah, I'm so pleased with them. The action is nice, the action is a little bit shorter, the pen overall is shorter, just refined the old design I had. I visually kept them looking pretty much the same, but internally, there's a bunch of changes. Changes that work with some of my machines here so I can produce them a little better, and more so, a bunch of changes to take manual work out of the equation. That's been my most limiting factor up to this point, is just the amount of manual finishing on these pens to get them where I want them to be. So I did my best to alter changes in CAD and CAM and the machining strategies to get as close to a perfect pen off the machines as I can. There's still a bunch of hand finishing to bring them up to the fit and finish that I want for a product that I'm selling, but significantly better than the old design. So yeah, in this video, we'll go over some of the changes, and we'll go over some of the kind of interesting things I'm doing on the machines to get a better quality unit. This body was turned in one turning, so that's a 5-inch stick out right now, but I did it Swiss style. I did it 1 inch at a time, slowly advancing the work out. And this is the amount of bird nesting I have. That's the new set of inserts I'm using. So, I mean, nothing wrapped around the part. That's the ideal thing. And that one I should be able to wash off with just some better positioned cooling. But yeah, Vision Metal Designs, I'll link them below. He set me hip to these inserts from Tungaloy. They're just like a nice sharp insert with a really good chip breaker for kind of low power machines like this lathe. But yeah, it works really well. So I got one specific for titanium, and finish isn't flawless, but for having a 5-inch stick out with no tailstock support and zero interaction with me, that's awesome. I'm very pleased with that because turning bodies is rather annoying, so I want to automate it. Problem is now parting it, but this lathe has a solution for that. So for turning the OD, I'm able to thread it past the turning tool here in between these two tool blocks, and I could turn a 1 foot part if I wanted to with this method. Problem is I can't part it because my parting tool is too big to sneak it back and get between here. There's just not enough clearance between all the blocks. I can take a block off, but I'm already low on tooling spots. So what this lathe has is this little gaffer. This is a slide tool, or like a parting tool. It's not very smart, just a hydraulic driven unit, but it has a little cutting tool here that will come and just part the body off. So that will work perfectly because then I don't have to try to get around this long stick out. So it's going to part it, then another tool will come in, clean the end up, advance the work to the next spot, and do it again. So I should be able to automate the body cutting, which would save me a bunch of time. This bit of code is my favorite. It has saved me so much time already. So what this is doing is turning the outside diameter of the pen tubes. It's a pen rod right now. It's turning it 1 inch at a time, then it's advancing the work out 1 inch and carrying on over and over and over. What this lets me do is get a really consistent outer diameter with a really consistent tolerance over its entire length, and then the hydraulic tool comes and parts off the blank, and I have a complete body with basically no interaction from me. I have to dig through the chip tray after the fact to find those bodies that kind of go tumbling off to nowhere land. But other than changing out the raw bar stock, it can run completely by itself until it runs out of material, which is awesome. This used to be a fairly manual process in the past, and yeah, this is a much better alternative. The finish is pretty good directly out of machine. Considering it's step turned like this, you'll be able to see the inconsistencies in the way the tool interacts with the material, but really, really close. Like we're within a thou over its entire length, which is easily going to be cleaned up through finishing. So very happy with that. A lot of changes to this design were not so much to increase the speed at which I can make it. For instance, this part is really no faster, but the tolerance is better and it is way more reliable. Here I'm using a parting tool to rough out most of the pen tip. The kind of pointy end is facing in towards the lathe right now. But by roughing it out fairly aggressively, the chip is very controllable, so when it comes back in to do the finishing pass, it does bird nest a little bit, but I put some code in there to strip away that bird nesting. So when it's done, it can part off a clean part into the parts catcher and move along to the next section. I don't have to worry about it snagging up tools, breaking stuff. It can just kind of function on its own. I'm not making a bunch of these, but just doing these changes across every single part has a massive, massive impact. And while I'm absolutely not a stickler for cycle time, I really don't care about cycle time. On an operation like this, I did some hand edits to the code to get the drilling operation how I want it to be, to get a really nice tight tolerance hole. But the side effect on this particular operation was I think it reduced the drilling time by like 400%, which is rather insane. I mean, it's not a long part to begin with, but hey, time. If I can save it, I might as well save it. One thing I will say is the fume extraction that I've been using, or the oil mist extraction, just blowing it outside, working perfectly. I am so happy with it. The air in here is so much nicer. It is notable, even with my lungs, without a fancy meter. I can tell that the air is better in here, so that's lovely. A nice metric for me to see if I'm reducing the amount of time that I have to be tending to the machines is how many more opportunities I have where both machines are running and I have time to take video like this. And it's happening more and more now, which is lovely. Here's another little silly change. It just works out so well. These little aluminum soft jaws that I put in my vices, they just kind of butt up against one side. I have op1 on one side, op2 on the other. I just flip them over and I can run op2. Like super, super easy changeover, and they work so well. Way better than I thought they would. So I don't normally have to edit code a bunch, but in this instance, this is some 4th axis code for the bolt slots. And in the past, there's always been a little area that I always had to have a secondary step. I had to remember something when I was cutting a bolt slot. It was always, oh, remember to do that thing blank so that the results come out exactly how you want them to. I just wanted to get that out of my brain. So I poured through the code, found the little problematic area, figured out a way to correct for it, and now the code posts out beautifully. I can just run it. I don't have to think about it anymore. The end result is pretty much the exact same result. Like it still comes out with a really nice final cut, but it's just no more mental load. It's off my brain now, which is a huge kind of quality of life improvement. That's what a lot of this design was too, is just take those mental loads out of my brain, because they might be small and they might only take me a second, but when you have 1,000 of them, they add up quickly. So anyways, I'm very pleased with how those worked out. The bolt slots on these pins are coming out lovely. They're a little bit smaller, like I said. I upped the chamfer a little bit just because it feels nicer, when your fingers sliding past it. And visually, it kind of catches the light and it'll catch the anodizing better. But yeah, I am super pleased with how everything is coming along. So with the changes to all the machining, I was able to get the bolt slot and the bolt slider pin tolerance a little bit tighter. I decreased it by about 5/10 tighter. So now that the pin slides in the body, actually if I don't put the air slot in the bolt slider mechanism anymore, it fully locks up. I left it without, just to try it before I put the slider in on this first version of the pen. This is actually the very first one I made, and I couldn't cycle it. It was super stiff because it was trapping air in the top section here between, essentially working like a piston, which makes me so pleased because that's what I've been going for the longest time. So yeah, I'm pleased that worked out. I'm putting the slot in there so the air can exchange back and forth between the mechanism, makes it go away, and I get the same action that I've always wanted to have in here. I'm deliberately not cycling this one because I actually don't have the correct spring in it, because I sold all the springs with the previous batch and I'm waiting for a bunch of them to come. So this one is like really stiff. But that brings us to another point, the spring in this pen. I deliberately designed to use an off-the-shelf spring that I can purchase. It's a 3/16 stainless spring. Eventually I'll go to titanium. I just can't source the titanium spring in the wire gauge I want for this pen. The old ones I made so I could just buy the titanium wire and make my own spring. For this one, I tried making my own spring for it. I actually tried a bunch of different variants and just never had something I was completely satisfied with. Once I did find something I was satisfied with in the size, it's very tedious to make. It's significantly smaller because I wanted it to be contained on the refill. Essentially, when you take the pen apart, I want the refill and the spring to stay together so they don't go kind of springing everywhere. It should either stay with the tip or it should stay with the refill. In the past, I wasn't able to do that because just a lot of different design choices, which is why I'm rolling this into a new revision. But the new one does, which makes me pleased as well. It adds to that one little extra facet of when you take it apart, you're like, oh, someone thought about this. So anyways, the ones that are shipping out are going to use a 3/16 stainless spring until I can source the titanium ones. Value add to the customer of having a titanium spring is nothing more than being able to tell somebody you have a titanium spring in your pen. You can't notice the feel. And honestly, the stainless ones probably feel better because they're made in vast quantities, so the batch tolerance is a lot tighter. The Nebula finish, these like entropic anodized parts are by far the most requested finish options I get for any of my pens for like the last forever. So a lot of these batches that are coming out initially are going to have these the Nebula parts on them. I put a lot of work into changing the finishing that I'm doing on these. They're all getting a very high polish now, which kind of makes that Nebula pattern pop even more and gives it a nice wet look. So I'm super pleased with how that's coming out, and with the cleaning process and the new nebulizing process I'm using to get this finish in the patterning that I like. It's easy to do. It's difficult to do with the complex patterning that I want, especially over and over and over again. It's easy to do one or two. It's much harder to do hundreds of them and get the same look. So yeah, I'm super pleased with this. On this last batch, I had 100% success rate, which is I'm very pleased with that. And yeah, we'll move forward with that. I don't know how much more I can toot my own horn about this, so we'll roll all the other weird nerdiness over to the next video. Thank you guys so much for watching. Thank you for buying my wares, letting me do this in my little garage shop. I enjoy the hell out of this. I'll see you guys next time. Take care. Bye-bye.